Good day to you from Chem Help ASAP. Let's discuss how the ideas of receptor ligands come into play when searching for new drugs. Our discussions of receptors and ligands has focused on competitive ligands. The ligands bind at the same site on the receptors. They compete for the same site. Remember, with enzymes, if you know the substrate, you can guess at possible structures of competitive inhibitors. In receptors, if you know the endogenous ligand, then you can easily guess at other ligands that might bind the receptor. Here's the catch. If you are designing an agonist, then being similar to the endogenous ligand is fine. You want to generate a response just like the endogenous ligand. If you are designing an antagonist, however, then you want to be similar enough to bind, but not so similar that you generate a response. This is a balancing act. Furthermore, it's surprisingly easy to make a molecule that has the opposite intended behavior. You wanted an agonist, but it acts like an antagonist. Let's see an example. Below are three structures. All are ligands for the beta-adrenoceptor. The first structure is adrenaline, which is the endogenous ligand for the receptor. The second structure is pindolol. This is a full agonist. It's also an exogenous ligand. It's an unnatural ligand. So it's a full agonist. It resembles adrenaline. Great. The third structure is carvedilol. Another exogenous ligand. It is an antagonist. These three structures definitely have similarities, though they are not identical. Still, it's hard to imagine that one of the molecules, pindolol, would be a full agonist, while the other, carvedilol, would be an antagonist. Tuning the activity of receptor ligands can involve many surprises and requires much experimentation. One final comment on partial agonists. Partial agonists are very flexible structures. A partial agonist that can cause a high degree of response, let's say 90%, is essentially as useful as a full agonist. The difference between 90% and 100% response is perhaps undetectable in patients. This is shown on the curve on the left. The curve on the right shows another idea. A very weak partial agonist, even though it causes a response, is actually much like an antagonist. If a partial agonist causes a response of just 10%, when combined with a full agonist, the partial agonist can overwhelm the full agonist and reduce response all the way down to 10%. This is almost the exact same suppression of response as shown by an antagonist. So, when thinking about drug activity, focus more on the biological outcome rather than just the type of ligand. In some cases, one type of ligand can functionally operate in the same way as another type. Thank you for watching. Please like and subscribe. Also, I enjoy seeing students' comments and questions, so please leave one of those as well. Take care.